All right, we're back, and in this segment, we're going to talk about twins. So, there are two different kinds of twins, two main kinds of twins. There are the monozygotic twins. We refer to them for shorthand as MZ for monozygotic, or a lot of times we call these identical twins. Identical twins are created when you have one sperm and one egg, depicted there in the bottom of this little diagram, that fuse together and create a new zygote. And as that zygote starts to split from a single cell to two cells to four cells and so on, as it starts to split, for some reason that really is not completely understood, the individual splits into two separate individuals. And at some point along their development, they develop into two different individuals. And they both implant in the uterus and they both grow and develop. With monozygotic twins, we consider them to be genetically identical. It's not always perfect, honestly. There are actually something like 27 different kinds of monozygotic twins, but believe me, we're not going to get into all of them. They're considered genetically identical, even though they're not going to probably be perfectly 100% genetically identical. Their fingerprints probably won't match. Their irises probably won't exactly match. There'll be different sort of striations and things in their irises. So they're not perfectly identical, but they are as close as you can probably get. So with genetically identical monozygotic twins, we have an interesting little laboratory where we have people who have exactly the same genes or very close to exactly the same genes. And so we can look to see whether their behavior is more or less similar to people who don't have the exact same genes or who share different environments and things like that. So we can really start to parse out the effects of genes and environments. Now on this little chart that I found, or this diagram that I found, you can tell I lifted it off the internet because it's got a watermark on it showing I didn't pay for it. So I apologize to the webpage I sold this from. It marks here, and I put a circle around it, that they always have shared placenta, which is not exactly true. I stole this picture from another source off the internet, which is a really great diagram because it shows us that on the left-hand side, there is the possibility for identical twins to have separate placentas. The placenta is, as you recall, the structure that connects the developing fetus or embryo to the mom. And so if the identical twins separate early enough after conception, they will have separate placenta. You'll notice not only are those individuals on the left-hand side of the panel having separate placenta, but they actually have separate amniotic sacs also. So they're each in their own little fluid-filled world. If you go in one step in from the left, it says fused placenta under that. So it looks like it might be one placenta, but it's really two placenta that attached so closely together on the uterine lining that they kind of merge together. So it looks like one placenta, but it's actually separate. So the two on the left-hand side are actually individuals that are in their own amniotic sacs, had their own placenta. The one, one step in, they merged together, but that was after the fact. They didn't start as a single placenta. The three on the right are examples of identical twins who have a single placenta. And then what's really different between those three on the right-hand side are the amniotic sacs. So you see the one that's smack in the middle there, it's called monochorionic diamniotic. So they've got one placenta and they've got two amniotic sacs. In the next one to the right, they have one placenta and they have one amniotic sac. So these twins are swimming in the same water as each other, but they're separate individuals. On the far right are conjoined twins. So in the far right, you have an identical twin set that separated into two individuals so late in blastocyst development that they actually didn't completely separate. So they're still conjoined at some point in their bodies. So they obviously are going to share the same placenta and be in the same amniotic sac. So I just wanted to clarify for you that monozygotic twins are not just one monolithic type of twin. There are lots of different ways and degrees that they could be connected to each other and have shared a uterine environment more or less. I mean, you can imagine that the uterine environment would be much more similar for the twins who are in the second from the right, where they share one placenta and they're in one amniotic sac, than if you are the far left identical twin, where you share all your genes, but you've got separate placenta and separate amniotic sacs, because things are going to be a little bit different for you during that, physical development in the womb. All right. The other main type of twin would be the dizygotic twins, and these are oftentimes referred to in the scientific literature as DZ twins. And in layperson's terms, we oftentimes call them fraternal because they're just regular siblings. They happen to have shared the womb at the same time. So what happens with fraternal twins is that mom ovulated more than one egg in a menstrual cycle, and they both got fertilized, and they both successfully implanted, and they both successfully developed. They share about the same amount of genes in common as regular siblings. About 50% of their genes are going to be shared in common. They always have separate placentas. They may again look like they fuse together, but they are separate placentas. So these different kinds of twins, the fact that they exist, allow us as psychologists to sort of separate out the role of genes from the role of environment. So if we find that monozygotic twins who were reared in separate households, which was a really common practice in the 30s and 40s, if they behave more similarly to each other than fraternal twins who are raised together, we're going to have a really strong argument for the influence of genes. If, on the other hand, there's no difference in the behavior of the monozygotic twins versus the dizygotic twins, or if it doesn't matter whether they were reared together or reared apart, then we're going to have a strong argument for the role of environment. That, really it's a very malleable trait, and it's more about what environment you experienced than anything else. So I want to make sure that I drive home this idea that on average, not only do monozygotic twins share more genes in common, but they are more likely to share a more similar uterine experience during their conception through birth phase. And that's a really important part of development. It's really common for people to sort of down talk how much is really going on during fetal development and how much there's an interaction between the developing fetus and the nutrition that it experiences, the amount of oxygen that it experiences, exposure to any kind of toxins or any kind of pathogens while they're in the womb. All of those things can have an impact on their physical development, like how they appear, how tall they are, how they depose their fat, things like that. But it also can have an impact on their developing brain. And so it can have an impact on their personality, their likes, their dislikes, their ability to sit still and be quiet versus the need to run around and be noisy. I mean, there's a lot of things that can be impacted by things that happened while the individual was in the womb. So twins give us insight into that also, right? Like if you shared a womb, are you in fact more similar on things than people who are regular siblings who didn't share the womb at the same time? So these are things that we're going to use as evidence as we go on through our, developmental trajectory. Now, I wanted to share with you, a lot of times people get confused about how exactly genes work. So here we have a couple. The father is mixed race, the mother is mixed race. They had a set of fraternal twins who are depicted here that don't even look related, really, if you were just going to go on superficial characteristics like eye color and skin color and hair, and you would think, how could possibly these people even be related, let alone twins? It's really important to remember that fraternal twins are just like regular siblings, so they only share 50% of their genes in common. And so clearly one of the twins inherited more of the dominant traits, and the other twin inherited a lot of the recessive traits, right? Because eye color is a dominant recessive pattern where you're, if you have one brown-eyed gene there, you will have brown eyes. So each of the parents obviously have one brown-eyed gene and one blue-eyed gene because look, they made a daughter with blue eyes. Each of the parents have variations in their skin tone genes that they could donate, and the one on the right inherited the lighter skin tone genes, and the one on the left inherited the darker ones, and so on throughout the very superficial things that we can see as different between these twins. It's really super important to remember the role of recessive genes. Now, I wanted to talk for a second about twins and triplets and more. Twins have always, happened across history, right? There's been identical twins that seem to happen kind of randomly. Then fraternal twins that seem to happen in that seems to be carried down the mom's gene, the tendency to ovulate more than one egg in a cycle. But what's really been interesting over the past 35 years is the increase in the rate of triplets. and what I'm calling triplet plus. So we were very concerned, sorry, up until, really 2006, we were like, holy cow, we're really having a huge increase in the number of triplets. And the reason why we're worried about triplets is that 7% of triplets and larger groups of children who are born together do not survive the first year of life. It's like 7% of triplets plus don't survive the first year of life, as opposed to 0.5% of singletons don't survive the first year of life. Which, by the way, 0.5% is way too high, not surviving for singletons. So 7% is just a ridiculously high number. And of those who do survive, they're more likely to have long-term morbidities, issues that could kill them, things that are, without modern medicine, they would not survive. So these are things that we worry about. Like, this is an important issue. The good news is that doctors have started to follow different policies when doing assisted reproductive technologies that could involve, embryo transfers, for example, because it's so expensive and things. They used to put kind of as many embryos into the womb as they had that were viable. They were like, well, let's see what sticks, and hopefully at least one of these will make it. Well, unfortunately, 3 and 4 and 5 and 8 were making it. And so now it was up to the parents to say, well, abort some of them. And a lot of the parents were like, no, that could endanger the remaining ones, and I don't want to abort my baby. And, all these ethical issues would come up. And so we were having a lot of moms that were giving birth to 5, 6, 7 babies. So one of the things that has changed is that doctors are less likely to transfer so many embryos, partly because the technology has gotten better that you don't have to put so many embryos in order to get a successful outcome. One thing that has not changed is the use of medications that in women who are having fertility issues because they're not ovulating. These medications can trigger them to ovulate, but they can also trigger them to ovulate multiple eggs, and that can contribute to triplets and beyond. And so that is still contributing to our much higher rate of triplet plus pregnancies. So you'll notice if you look at the rate of triplets prior to the advent of these kinds of assisted technologies, the rate per 100,000 births is on the left, and so you see that it's less than 50 triplet or more sets per 100,000 births. If you look at, that's the blue line. If you look at the right-hand y-axis, what's that called? The Z? I don't know what it's called when you've got two y-axes. This is the raw number of births. You'll see that in 1980 numbers, we're looking at, in the entire United States, just slightly more than 1,000 births of triplets or more. Whereas today, we're looking at, 4 times that. So it's problematic because of the harm to the offspring. It's also problematic for mom because pregnancy with a singleton is a lot. Pregnancy with a set of twins is a lot. Triplets or more is very taxing on mom's body, and so we worry about it for both the offspring and for the mom. I just wanted to put on the bottom there that I got all of this data. It's the most recent data that the CDC is reporting, and so I got this off of, it's an article that I got off of the CDC website, and here's how you could find it at the bottom. So twins are terrific experiments for us in psychology, for us to, explore the role of genes and environment on certain outcomes. Triplets and beyond, they're a little bit of a conundrum for us. And so, like most people wouldn't volunteer for triplets and beyond, I think, is like a simple way to say it. All right, let's go ahead and take a break here, and we'll come back and talk about epigenetics in the next segment.